And next we have Ian, who is going to talk about systems thinking in space. And hopefully you can see that as well, Leah.
Thank you. Okay, conscious of time, I'm actually going to try and squeeze this down. So this will be a fairly rapid run through of a particular framework that we use in our teaching, and we use it both for our MSc programs in system engineering. It's also something we include on our space system engineering course that we deliver to ESA. So, and it fits quite nicely in with some of the other things that have been talked about. So obviously, yeah, my specialist area is systems engineering. I'm not going to talk through that picture, but it's really just to highlight that everything we do in system engineering is backed up by system thinking. You can't do systems engineering without system thinking. So I want to present a framework that we use to try and help people with that kind of system thinking. And you know, we often, you know, other people have said it here, trying to get students to think about the broader picture is something that is something that we find challenging. So again, this may be a framework that you find interesting to allow you to do that. So it's called the Seven Samurai of Systems Engineering. Anyone heard of this before?
Star Wars.
Or am I just I'm presenting something new, which is always nice. I'm going to use Euclid as a background, so that's where it kind of trying to link into how would you use this in a space example. I haven't worked on Euclid, and I'm not an optical engineer, so if there are mistakes, yeah, allow me those. So the fundamental thing about this framework is really that we start with thinking about what's the context in which we are developing this system. I think someone mentioned before that people love to jump to a solution, to think about the thing that is, I've got a really good idea, this technology, this. This is pulling them right back to the beginning. What's the context? That's our first system, and I saw a very similar list on one of the other presentations in terms of thinking about the bigger picture of where is our system development going to sit within, because all of these things will impact you in terms of your development. So you can see here, you know, just some examples of if you were to apply that to Euclid. The context is, you know, we have these scientific questions that we're trying to answer, and we need a better understanding. So that's our first problem. So we're trying to solve a problem. Anything we create is trying to solve a problem. So in order to try and solve that problem, we think about an intervention system. So whatever it is that we are designing, building, putting into operation, we refer to as our intervention system. Here, we're talking about a telescope mission. So that's the thing that we're thinking about to try and suppress the problem. We think of everything as a system. So in order to create the intervention system, you have to have a realization system. And by that we mean all of the organizations, the supply chain, anything that is necessary in order to make that intervention system come about. So here again you can see we've listed all the ESA bits, you've got the consortium, you've got all the suppliers, you've also got the other things that exist like regulations, existing technology, etc. So that's now our third system, the system that creates the system that we're trying to intervene with. And that intervention system then becomes the deployed system. The reason we include that is the thing that you know, as built is not always exactly the same as designed. So again, it's making them think about, okay, in order to turn my intervention system into my deployed system, you have to think about all these things like design for manufacture, design for integration, design for test, configuration management, all those sort of engineering-y things that we have to do because of that transition. When we deploy a system into the world, we change the world. So we're also, this makes them think about, okay, when I put this mission into place, when I put this product into place, what does it change about the context? And can I predict some anything about that modified context I can take into account now? Because our new system may cause new problems. So can we foresee some of those problems, and rather than saying, okay, I've just created this problem, so now I'll create another bit of technology to solve the problem I've just made, can we get them to think about that early enough that we suppress those or think about those problems earlier on? We need to think about collaborating systems, so anything that our system has to collaborate with, so getting them to think about what's the boundary of my system, who do I have to work with, what are my interfaces, therefore what do I need to design in my system to allow me to collaborate with these things. And we might also have to think about sustainment system. So what is it that allows my system to continue in operation? So that's kind of a whistle-stop tour of the Seven Samurai Systems Engineering. So it's a framework that anyone can use, and just might help getting students to think about the bigger issues or the bigger problem that you are trying to develop your solution within. And the last one on here is competing systems. So just also thinking about what might I be competing with, which might inform the requirements of the system I'm developing. So there is a paper on that, so if you want to go and read about it, there's obviously a lot more detail in terms of each of those different systems. But might be a useful framework for you to have a look at. And so this is really the key points which I've been saying is we often focus too much on that thing that we are making, and the framework here just helps get students to think wider about all the different systems that exist as we go through the life cycle. And people have taken this and developed it further. So one of the things that we often get asked when we present the Seven Samurai is, when do I do this? So this really is saying, actually, you don't just use it once, you can use it as you go through the life cycle. So you can also use it as a tool to think about the life cycle and, okay, what's the evolution of these different systems through the life cycle, and do any other things appear? So again, it's also, if you want to, you could also get students to critique the framework. So that's another piece of assessment you could possibly do, again, which forces them to think about, okay, what's the point of the framework and how do we use it and is it useful? My main comment on that framework at the moment is sustainability is not sufficiently emphasised. So that's one thing that, I would probably add another thing on there. So that was it. Very, very, very whistle stop.